IFR training videos. By
Toga thrust.
Approach chart description. Consider an ILS chart, EBCI. 1. Title of the chart, Charleroi, ILS or Log 24. 2. Chart number. 3. Date of effectiveness. 4. Date of revision. 5. Airport ICAO, IATA code. ATIS frequencies, D, means you can obtain ATIS via ACARS. Approach frequencies. Tower frequencies. Ground frequencies. Localizer frequency with localizer ident, India Golf Charlie. Localizer final approach course. Final approach fix, FAF, altitude, here at 7.6 DME from India Golf Charlie lock. ILS decision altitude, height. Airport elevation, runway elevation. Missed approach path description. MSA, minimum sector altitude, and reference, Gulf Sierra Yankee VOR. Altitude setting in hectopascal. Runway elevation in hectopascal. Transition level, here by ATC. Transition altitude, here 4,500 feet above mean sea level.
Plan view.
Area remarkable points. Special area, here, R, for restricted. Close obstacle elevation. Depicted nearby airport. Highest elevation depicted on the chart. Special notes referring to the lateral navigation. Approach key lateral informations. ILS information box with front course, frequency, ident and Morse code. NDB, outer marker information box with name, frequency, ident and Morse code. VOR information box with name, frequency, ident and Morse code. Initial approach fix. Initial fix. Center fix. Final approach fix. Outer marker, NDB. Middle marker. Go around RNAV fix. Different legs of the procedure. Holding. Positioning turn outbound. Positioning turn inbound. Procedure turn outbound. Procedure turn. ILS inbound.
Profile view.
You look at the vertical profile of the approach. With position of the initial approach fix. Maintain 3,000 feet altitude until procedure turn is completed and final approach fix is reached. Descend on the glide slope, see table for slope and vertical speed. Check the outer marker at 1,800 feet QNH. Continue to the missed approach point. You have to combine the lateral navigation with the vertical navigation. After the holding and, or first positioning turn, if any, starts the approach itself. For this approach, overhead the initial approach fix at 3,000 feet. On the outbound leg at 3,000 feet. During the inbound turn at 3,000 feet. Until the final approach fix at 3,000 feet. From the final approach fix, descend on the glide slope with the depicted slope, standard, 3 degrees, 5%. Check the outer marker at 1,800 feet on the slope. Continue down the slope to the MINIMAS, see next. In case of a go-around, follow the dotted line as written in the missed approach description. First to Charlie India 24 Tango, 6 DME on radial 244 Golf Sierra Yankee. Then turn right to Golf Sierra Yankee VOR climbing to 3,000 feet. Between the plan view and the profile view, you find the descent scale in case of loss of glide slope, or to cross-check the slope accuracy. You may find this information in some other place on the chart also, but less often. For each DME reading, based on India Golf Sierra ILS DME, you must be at the altitude specified in the table. This can confirm your altimeter setting or the validity of the glide slope signal. Usually, if the outer marker check is valid, you will not use the descent scale further on a full ILS. Be very careful about the distance reference as it may not be the one expected, sometimes another VOR instead of the ILS DME. Below the profile view, you find the glide slope in degree, the rate of descent depending on your ground speed, the position of the missed approach point, here at the middle marker or a 0.8 DME based on India Golf Charlie. The basic equipment of the runway, HIALS equals High Intensity Approach Light System. PAPI equals Precision Approach Path Indicator for example. The initial phase of the go-around, straight ahead with maximum 185 knots on Golf Sierra Yankee radial 244, frequency 115.700. Last but not least, you find the MINIMAS table. There you will find straight-in landing MINIMAS, when you land on the runway for which the approach has been designed straight ahead. ILSDA, H, 776, 200, means that, for the ILS, the DA, decision altitude, is 776 feet and the DH, decision height, is 200 feet. Decision altitude is AMSL, above mean sea level, you read it on your altimeter set on QNH. Decision height is AGL, above ground level. As the cloud coverage is based also AGL, you need a ceiling of at least 200 feet AGL to see the runway. Is that important for an ILS? For a precision approach, now called a 3D approach, you only need a visibility or RVR, runway visual range, to be legal to start the approach. Of course, you need to see the runway when you reach the MINIMAS, otherwise you must perform a go-around. For a non-precision approach, now called a 2D approach, you must meet both values. Minimum ceiling and minimum visibility, RVR, to start the approach legally. For the ILS, you have three possibilities. If the runway equipment is fully operational, you need an RVR of 550 meter, R in front of the number means RVR. If the TDZ, touchdown zone lights, or the CL, center lights, are inoperative, you need an RVR of 550 meters as well. But if the ALS, approach lights system, are inoperative, you need an RVR of 1,200 meters. And this for all four categories of aircraft. Categories? What categories? There are four different categories of aircraft, labeled A, B, C, and D. They are based on final approach speed, named V, A, T, or threshold crossing speed. Have a look at this ICAO table. Is that all? No. As we see, there is a Note 1 in the remark field. Note 1 says that, the RVR must be raised to 750 meters if a flight director or an autopilot or a HUD, head-up display, is not used until reaching the DA, decision altitude. So in case of a touchdown zone lights or center lights failure, there is that parameter also to be taken in account. What happens if there is a glide slope failure? Then you may fall down to lock only, glide slope out, MINIMAS. It means that, if the failure occurs before 1,000 feet AGL and, that you can reconfigure the approach, settings, MINIMAS, and brief the difference to the crew before reaching 1,000 feet AGL, then you can continue the approach as a lock-only approach. That means that you will rely to the descent scale for the descent, not to a glide slope. Remember the descent scale we saw before? To be able to shoot that approach legally, you must have a minimum ceiling of 404 feet AGL, and a minimum RVR of 1,200 meters, if the runway equipment is fully operational. In case the ALS is inoperative, the MINIMAS are raising to minimum RVR of 1,500 meters for Category A and B aircrafts, minimum RVR of 1,900 meters for Category C and D aircrafts. The Note 2, used only for the lock-only, glide slope out, approach, means that instead of using a MDA, H, the operator may choose to use a DA, H, if flying a VNAV. What is the difference between a MDA and a DA? And what is a VNAV? MDA, H, is for minimum descent altitude, height. You cannot descend below that altitude, you have to plan your decision to avoid descending below that value. DA, H, is for decision altitude, height, the lowest altitude where the go-around continue decision can be made. If you take that decision exactly at that altitude, height, you will descend slightly lower during the go-around procedure, but it is allowed. VNAV is for vertical navigation, where the airplane systems compute a glide slope, computed on board, not received as in an ILS, depending on your QNH, so if your QNH is wrongly set, there will be an error on the glide slope shown on your instruments. Last information's in that table, the circling MINIMAS. All the other numbers are dedicated to straight-in landings. But what if the landing runway is not the one for which the approach has been designed? Let's say that, due to a reason, you must make the ILS approach on the runway 24, but you must land on the runway 06 due to the wind. In that case, you have to apply the circling MINIMAS, for Category A, 1,220 feet AMSL or 614 feet AGL for the ceiling, and a visibility, yes, here it's a visibility, be careful, of 1,500 meters, here we talk about an MDA. Wait a minute. What means that PAN's OPS text on the left side? PAN's OPS is an air traffic control acronym which stands for Procedures for Air Navigation Services, Aircraft Operations. PAN's OPS are rules for designing instrument approach and departure procedures. To finish the description, at the bottom left of the chart, you can find the changes that have been done on this last edition.